Our speaker this evening is one of the co-founders of Chicago's Hadoop community. Please welcome the Director of Enterprise Strategy and Architecture at MapR, Jim Scott.
All right, thanks everybody. Glad to be here. So one just minor point of clarification, MapR. That's okay. Oops. Sorry. So I personally, as a little background, co-founded the Chicago Hadoop Users Group. I was a former customer of MapR, used MapR to build a platform that supported 60 billion transactions a day in ad tech. I've done quite a bit with it. And I'm not here to bash RDBMS. I'm not here to bash any other products. I just want to make sure people understand that, because there might be some things you hear that as I'm talking through, it might come off that way. That's not my intent.
Your microphone just died. Just switch that.
They've also got a megaphone. Is that better? Yep. All right. So there's a bunch of different technologies that are going to fall into this space that we're going to talk about today. My hope here is that everyone gets to walk away with perhaps a slightly different perspective than what you might be accustomed to. Some of the things that I'm going to talk about might not be too far off from what everyone is doing, but the goal here is just to be thinking different. And part of my rationale for this is that relational databases for well over the last 20 years have been the solution for nearly every enterprise problem that's existed. I've long been told that most people in technology's goal is to use the right tool for the right problem. Now, a lot of people say that, but very few people practice it. Most people are much more willing to practice what they can actually get into production. And I say that from firsthand experience. So, what are we talking about here? Well, in my personal experience, I think about 90% of the use cases that are out there don't require a relational database when you're looking at the problem you're trying to solve. Now, there's a lot of problems that require relational semantics, but the use cases that I've dealt with for at least 15 to 20 years now have dealt with what I typically consider to be autonomous records of data. So user records, logs, things that, while the structure is similar to other things, they are not intertwined pieces of data, right? They're not always accounting systems. So when you start looking at the why for many of these use cases, what typically happens is we've got people who say, I need a place to persist my data. And when they say I have to persist my data, well, what's supported by the IT operations teams? Relational databases. So while the data is not inherently relational, generally it tends to be more hierarchical than anything. Mapping those relationships to database structures is pretty complicated. And so when you start getting into the amount of code that it takes to come up with an object relational model and get your data out of your code, data structures, into your database, there's a lot of work that goes on. When you start looking at the relevance for the use cases of the relational data, we see a lot of trade-offs. Creating special keys to make access to the data faster. These are things that we've grown accustomed to make it so that our use cases can perform to the highest performance capabilities that are required to meet the service levels we have. So when you start looking at lots of different use cases out there, I don't know, maybe if you're anything like me, have you ever dropped keys off of a table to get data to load faster and then put keys back on later? Anybody? Yeah. Yeah, so you know, we make these sacrifices all the time. We work around functionality in relational databases because there's a lot of cases here where we don't require relational semantics. It's just a persistence store. And so one of the other problems that we have is when we start looking at transactional use cases versus analytical use cases. What do? We build ETL. Well, has anybody here ever taken a transactional database and converted it to an OLAP model or a star schema model and gone through an evolution process of trying to get changes from transactional into an analytic database? What's the average time it takes to make changes to a star schema when you have changes in your transactional database? Anybody?
Stupid.
Stupid? That's a great answer. Anything that takes more than, I would say, days, kind of, to me, falls in the realm of stupid. So on average, my personal experience is it's pretty much 3 to 6 months to get changes from the transactional system fully modeled over and evolved in the star schema in the data warehouse. That's a lot of time. So this is fundamentally what we're talking about here. So as we walk through here, this is how I've got it broken up. I want to encourage you to consider swapping out your data models. And again, I'm not telling you to walk away from relational databases. That would just be flat out stupid if you've got relational data. Don't try and squeeze relational data into a NoSQL database. Okay? How many people here have worked with the Hadoop realm of technologies since, say, 2009? Few people. Okay. So I've been working with it since 2009 myself. I have firsthand seen people try and use Hadoop to solve every problem under the sun. Why? Because it is a naturally distributed platform. So since it distributes well, people want to make it work for anything. Problem is, it doesn't just work for anything in its base implementation. So we've seen all of these offshoots come to solve all the different specific problems, but what they've done is they've leveraged a lot of the ideologies underneath the covers from this Hadoop model. So we've now got options to be able to run this naturally distributed model. So truly, people have the opportunity now to start picking the right tool for the job. So what I'm encouraging you to do is not just throw the baby out with the bathwater. I'm encouraging you to consider your options. And I think this is where you can do the most justice for any company you're working for, is to say, be thoughtful about your options that you have. So my goal, ultimately, is to get everyone to the point where you can get to be an as-it-happens type of business. So I talk a lot about enterprise architectures. That's not what I'm trying to talk about today. But my goal is always to try and enable everyone to be as real-time as possible. I've gone through implementations where I told our data science team when I was in AdTech, I said, well, I want you guys to start evaluating the tools you're going to need to be able to implement your new models within about 6 months from now. Because that's when we're going to be ready for this. They said, no, never happened, never happened. It took them over a year till they got to the point where they said, oh my gosh, we have to do this and we're 6 months behind. And so they finally, at that time, for that organization, they started looking at Apache Spark. So my experience is that most people wait until it's too late to even start considering something. And by the time they start considering it, they've got a manager breathing down their neck saying, why haven't we figured this out already? You should have already known. You should have already been thinking about this. So fundamentally, what I want everyone to think about is schemas like this. Anybody ever work with a schema like this? Everybody's worked with a schema like this. So this is actually a music database. This is a real, legit music database. Except there's 180 tables that I'm not showing you because it wouldn't fit in the diagram. So has anybody worked with a model like this? Right? This is pretty common. Now, if you're a data analyst, are you ever going to be able to make heads or tails of this data model to know how to join these tables together the proper way to get valuable data and insights out of it? No. Everybody probably already knows that, and that's why we have this OLAP model, right? We model the data differently so that people can understand what's actually there. Right or wrong, it's what we do today. So fundamentally, when I break this down, this model has 236 tables to describe 7 different things. Why is that? Well, it's because we've got this massive fan out of one-to-many relationships of what is effectively hierarchical data that we've modeled. Some cases here we have for speed and performance. Other cases we try to reduce data duplication. Whatever the answer is, it kind of doesn't matter. It's just a pain to work with. So when I look at a use case like this, and in this use case I've got artists from a music database. 7 tables, right? Well, if I pull this back into a more normalized type of view, I get this. Notice that I have some lists down here that this screen just absorbs the laser so you can't see it. But The last couple things there are lists of things. Well, you can't do lists of things in a relational database, right? You end up creating additional tables, and then you do one-to-many relationships. Complication. Well, if I get a little more creative here, I can actually represent all of my different types of data that I have here, and I have fundamentally the same concepts that I have in a relational database, but I can pull this back into one single model. So at the bottom, the last two things there, release ID and recording ID, they're equivalent to indexes, because if you think about the purpose of an index, what is an index in a database? Do you ever use an index directly? Nope. They don't expose indexes to you to use. Indexes are behind the scenes for the database to operate faster. So if you decide that you want to have something like an index in your data model, you should feel welcome to go ahead and do such a thing. But in this case, it's for you to operate on. It's not necessarily required depending on the database you're using and how it's implemented. Right? Sometimes you want that ability to have a secondary index. The question is, how are you going to leverage it? So what I think is kind of a fun way to talk about music data is to search for Elvis. So if I had all this data rationalized down to this one table view, number one, anybody who looks at it can understand what each of those fields are, right? I have lists of things, but otherwise they can understand what all these mean. And so when it comes to writing a query, right, I may otherwise have to join 10, 15, 20, 40 tables, who knows, to find what I'm looking for. But in this model, a query like this is all you need to be able to do to get at the data. So some of the benefits that we're talking about here is when you get down to simplicity, there's a huge benefit, right? It's a big payoff to enable people to get at the data and understand it without having to have an extra degree to understand these models. So being able to have a 20x reduction in your table space, that's pretty compelling. So when you get to being able to do that introspection, conceptually this is great because it means you can open up the door to your data to more people. And when you look at a tool like Apache Drill, being able to enable SQL on top of a simple model like this, you don't have to give up a skill set of SQL, right? NoSQL came out, and it literally meant no SQL. Like, we don't want SQL. We've got these technologies that scale, but you can't use SQL with them, right? Because the inherent implementation models of RDBMSs really prohibited easy, cost-effective scaling. That's not to say you can't scale a relational database, because you certainly can. However, the cost and effectiveness is drastically different than a NoSQL database. Now, what happened, does anybody know what happened to the term NoSQL? What is NoSQL referred to now? Not only SQL. So we backronymed it into something else because people were like, oh, man, like we had this really cool thing, and then it kind of like went away because like you can use SQL on top of these NoSQL databases now. Well, it's a really great thing because if you break it down to the most fundamental thing, SQL is just a language. So if people understand the language, why not enable them to use it? So simplicity, drill, data, get at it with SQL, great combination. You don't require a relational database, you don't require a Hadoop cluster. You can let anybody start getting at raw data with drill. So where do we go from that? Well, I'm going to go through and give more examples of what you can actually do with drill. How many people here are actually familiar with drill? I expect very few. There's like 2 hands. So we will cover that in depth a little further. So I like the concept of putting your data into JSON format. And what's important about this is now, I'm not going to badmouth MongoDB, but I have plenty of friends who, they love the APIs and simplicity of MongoDB, but they hate certain features and lack of functionality of MongoDB when it comes to scaling, resilience, or not losing data. Now, MongoDB has really helped set up what it is that people should be able to do. Now, I don't think it's quite caught on to the level that it could have, but the fundamentals are there, and that is a document database, a simple API. Well, there's also now this OHI API. Now this happens to be what MapR implements in MapRDB. So MapRDB, if you're familiar, implemented the HBase API in its onset, and now has this OHI API. And the OHI API is a document API that uses JSON. So the entry points that I have listed here, just a few of them that are here. The API is one of the simplest APIs you'll see out there for dealing with document data. So let's see what it takes to work with JSON. Well, this JSON library is a Google JSON serializer. You create an instance of it, and then you take your POJO that you have, and you serialize it to JSON. That's it. It's one line of code in Java. I guess technically the creation of the JSON object is one line, so that's two lines of code. I'll give that to you, okay? Now, in any language that you're in, you're pretty close to looking at effectively one line, maybe 2 lines of code to serialize your data structures into JSON format. Now, compare that to how many lines of code it takes to serialize your data into a relational model. Anybody? More. That's a great answer. So I've never had an enterprise solution that has had less than probably a few thousand lines of code to serialize all the data structures that we have. Comparing that to a line of code to serialize to JSON. How do you deserialize? Well, that's another 1 line of code. It's really complicated. The nice thing here is that when you start looking at using a JSON document to store your data and persist your objects, is you got 1 line of code to serialize, you got 1 line of code to deserialize. Now let's look at the other benefits here. Anybody can come along, deserialize that code into JSON format, or from JSON into the data structure, or into any specific language they have, and they can start working with it. So if you're using a tool like Drill, that's awesome. But if you're not using a tool like Drill and you're using a language to deal with it, that's easy. So you open up the doors to more people, and because it's JSON format, it's self-describing. I mean, if you use really horrible variable names, that's on you. But it enables you to use nice descript names. Real easy. So when you're dealing with documents, this is all there is. You've got a builder syntax. You can stream the data. It's easy to work with. So when you want to create documents, that's it. You don't even have to serialize in this API first. You can just hand it your document. So depending on how you want to work with your data, you can really get it down to 1 line of code, and it will handle the serialization for you into the JSON format. Alternatively, being able to do an insert or replace on a full document, pretty convenient. Again, since you don't have to worry about serializing to a whole bunch of different tables, right? You can replace a whole document like that, nice and easy. You don't always have that as a use case, though. So when you want to update existing documents, you come in and you say, I want to mutate my document. Well, that's pretty simple. So you build a mutation. So I've got some examples here. Again, the API is extremely simple, but when it comes down to it, most mutations kind of fall in this realm. Now, the nice thing about a document database is that you've got this capability to be able to make modifications directly inside the database. So this append that you have here, that's a really great example of compare it to quite a few of the key value stores that are out there. If you want to use a key value store to do this type of append operation, typically what you have to do is you have to pull your object out, make an update, and then push it back into the database. Well, with the document store, you just make the change inline. You say, hey, database, do the work for me, append to this. So if you have an array of URLs that a person visited, just append. You can do blind appends. If they're time-stamped, that's even better because your transactions that are occurring are going to be idempotent. Anybody know why that matters? Anybody? So it's going to matter when you come across use cases to say, I don't want to have to worry about repeating something more than once and having a different, well, performance potentially. But the importance of being idempotent is how you write your code can vary. So you can have the ability to listen to actions coming off of a stream, and you don't have to worry about replaying something twice. So if your processor listening to your stream of data happens to pick one up and then die, you don't actually care if it went through the database because idempotent actions they'll repeat and produce the same output.
So what you're saying is this has implicit referential integrity in the database scheme of things?
I would not say that it has implicit referential integrity, because referential integrity has to deal with when you're going across different data sets. So all of the transactionness that occurs in this database is going to be based inside the record. So if I make changes to 3 fields inside this document, and you're making changes to 2, the transactional ACID natures that exist for this record will guarantee that not one update and then yours 2 show up and then my next 2 show up. My 3 are all part of one transaction. Those 3 will land and then your 2 will land.
How is that guaranteed?
Well, it depends on
It's based off of how the database implements changes coming in. So you can also do things like incrementing counters here. And again, another great use case of not having to pull an object out of a database, just to be able to set it. So again, NoSQL database is smoking fast in general terms. Document database gets into the nice functionality of, hey, I'm going to make it even faster for you to be able to make these changes. So you can just blast the changes into the database and it will handle this right in the document. So what happens when you want to start deleting? Well, it's really super complicated. And I really pay attention to this, okay? This is, if you're ever going to work with this type of technology, this is the most important thing. That's it. You just say delete. It's really just stupid simple. So you can give it an ID or you can give it the actual document. It'll take care of it. It's really easy. So it's kind of almost too easy, right? When you want to start finding documents, what do? What are your options, right? Querying the data matters. So this is where we get into, you have to be thoughtful about your technologies you choose. Now, document databases, generally considered a NoSQL database, okay? What that means is the first class API that occurs is going to be the API. The second class is going to be a SQL interface. So if you want to programmatically work with the data, you are always going to be best served working with the API. So when you've got use cases where you want to query the data, you could go through the SQL interface to query data. But if you're dealing with these documents in programmatic terms, right, you're building a web interface, you want to work with the document, you're probably best off dealing with the actual API and going straight to the data. It's not to say you can't go through drill and query the data, you can. But in general, consider the 2 interfaces for their intended purposes. So when you want to start querying the data, it's pretty dead simple to come into the document database and say, well, this field is like this, or not like this, or whatever. Ands and ors, put it all together, real easy to handle. When you're dealing with strict NoSQL databases that are predominantly wide column oriented or key value, you can't do anything quite this simple. Much more complicated. It requires you to build some type of secondary indexing to be able to get at the data and query it effectively. Otherwise, you're only going in after the keys generally. So, I'm talking about JSON. So if I'm talking about JSON, I've shown you the OHI API. So the OHI API, simple, open, easy. MapRDB implements it on top of its JSON store. So that's how you get that data. But if I'm telling you you should be using JSON, and I'm saying you've got this OLTP thing, right? You do ETL, you OLAP, open it up to the other side of the house. What else are we talking about? Well, this is where something like drill comes in. So the goal of drill is to marry the concept of anything with SQL. So drill fundamentally is a SQL query engine for anything. Now, it's extremely important when we start looking at JSON document stores because you want those people who are going to be doing effectively general queries to be able to get at the data easily. So when we take the familiarity of SQL with the agility of NoSQL, we end up with Apache Drill. Now, drill is very different than all the other SQL on Hadoop technologies. Number one, drill does not require Hadoop. You can run it on your laptop. The trivia question at the beginning, what do you require? Java. If you've got Java on your machine, you can download drill, install it, and start running it. It will take you, well, if you go to the website, it'll say 10 minutes to get started. If you have a really slow internet connection, it's going to take you 10 minutes. If you have a fast internet connection like I do, it's probably going to take you about 1 minute to download, maybe 1 to 2 seconds to unzip it, maybe another 2 seconds to start it. And then you can start querying data with it. That's all it takes. What's nice about it, though, is this little detail right here, schema on the fly. This is where drill blows all the rest out of the water. So the idea here is that with JSON records, anybody ever pulled JSON off of a REST interface? Good number of people, okay.
Yeah.
So if you serialize a document to JSON and you have fields that are empty, does JSON serialize, or do JSON serializers output empty fields? In general, the answer is no. Okay, so when you're going record by record, you've got to have the ability for something like JSON to be able to understand the schema as you go. Because you may, for the first 10 records, have this field not exist, but then the next 10 records, the field exists and it's an integer. Now, drill does not get around people being stupid and changing data types on the fly. Right? If you used to have this data type as an integer, and tomorrow you change it to a string, that's your problem. Drill can't help you with that. It's going to blow up and it's going to say, look, you've tried changing data types, they don't work. You can cast, right? You can try and get around that, but it's probably not going to give you your desired results. So it does not detract from good data modeling practices and understanding what the data is you're actually dealing with. But because it has this flexibility, it gives you the ability to take different data formats in different sources and join them together on the fly. So you can join JSON with CSV files, with MapRDB, with HBase, with Parquet files, whatever you want. And as you go from columnar to anything, like JSON, right? You could always represent columnar as a very simple JSON document, right? If you took this and said field is name, field is gender, field is age, and you would create one record for each of those, it's going to look a lot like this. So drill has the ability to take these data sets and effectively normalize them. So you can join them together on the fields that you specify. And so one of the things that drill does that the others don't do is the others predominantly depend on Hive. Well, Hive is a metastore, or has a metastore with it. And what they require is a definition of what the data is. Drill says, look, you know what? You know your data. Give me the query and I'm going to run. So if you know your data, why do you have to go through a process of creating an entry in a metastore that says, here's what my data looks like? Well, drill can figure it out on the fly as it goes. And since you can query across data sources and across data formats on the fly and join them together, there's some pretty convenient power. And to exercise this, here you can see district exists here, preschool exists here. If you're querying for those fields, great. If you're not, who cares, right? The data's just going to get thrown out anyways. But again, you know your data better than the tools do, and this doesn't require you to go through an administrator to start using it. So when we get into that concept of as it happens, well, it's kind of nice when, you know, this whole idea of Hadoop was to enable people to more rapidly do things, break down the walls of the data silos. Now, it has to some extent delivered on that, but it's missed the mark pretty heavily because of certain limitations in the Hadoop infrastructure. Well, this is part of what drill has shown up to try and help solve. So when we look at it, ideally, the goal was we want to have self-service data exploration, right? People have been talking about this for a solid 15, 18 years-ish, right? So we moved forward, and the data visualization has, in fact, become self-service. Tools like Tableau, MicroStrategy, right? These tools have come a long way to help people be able to visualize their data in very effective ways. Takes a little bit of training, they're up on it, they're good. So what happened next was we said, wow, SQL on Hadoop is here, woo! We can run distributed queries across big data. Yeah. That's great, but nothing changed. All of the same processes still had to exist, right? What we did was we swapped out the relational database with Hadoop. So our data warehouses have slowly been evolving to data warehouse offloads, putting data onto Hadoop, and doing SQL on Hadoop. But ideally, the goal really here is to enable this optional capability. And I say optional because ETL isn't always a bad thing. I just think it's a bad thing sometimes, right? We've fallen into this pattern of, well, this is how we've done it in the past, so let's just keep doing it that way. So a lot of people do technology swap out of technology A for technology B. Great, but if you're not going to reconsider your internal business processes and look at other potential benefits, then why are you swapping the technology out? Maybe it saves you a little bit of money, maybe it doesn't. Look at the bigger picture benefits that you can derive. And so when we get here, we have the ability to kind of hit this concept of zero-day analytics. That means you don't have to wait for the data to go through a transformation process. If you find a new data source, you don't have to wait for your enterprise data warehouse schema to evolve to be able to accommodate this new data set that you have for you to be able to run queries and join these different data sets together. You can now pull in your data set and join it with your effective data warehouse data that you've offloaded onto Hadoop, and now you can join them together on the fly. And it doesn't require someone else to go in and say, here's the schema, here's how it works, here's how you join it. You already know. It's your data, right? It doesn't matter who it is that wants to run the query. They've got some new data set they want to test out and play with. Well, why have to go through a full production process to prove out whether or not a new idea is going to work? Right? That's the benefit of these tools. Accelerate people's ability to succeed. So when we kind of get into the common use cases, raw data exploration, JSON analytics, data warehouse offload, pretty common things. Well, enabling those through the tools people are already accustomed to is really a big deal, right? Again, my stance is I want people to be successful with technology, so choose the right tool for the job. If your organization has made an investment in a tool, there's probably a reason why. So instead of throwing the tool out and saying you have to replace the tool in order to use this awesome new big data technology, wouldn't it be better for everybody involved if you could just keep using that tool? Well, this is where Drill comes in. It plugs right into all those tools. So you've got the ability to go against all these different types of data formats and data sources, join across them, and pick up the capabilities. Now, I know a number of people who have been using Drill in production environments for well over a year now. Sometimes people say, you know, the SQL on Hadoop technology, and I say this in general terms, not just Drill. They say, oh, it works great for this use case, but then bleh, for this use case. Well, Hive was really the first SQL on Hadoop use case technology. Hive worked fine after you tweaked and tuned it. There's a lot of parameters to be able to get it to run efficiently. Was Hive the end all? No. That's why other tools have shown up. The core here, though, is that for each of these technologies, they're each going to have cases where they excel. So if I said, Drill is going to run really fast for, say, 98% of your use cases, you're probably going to come across some 2% use cases periodically where you're going to make it go slow. All right. Some of those can be solved by changing your data formats. Some can be solved by storing your data differently. But at the end of the day, it's going to change your work processes for how you get at the data because you don't have to go through necessarily all the same ETL processes. You don't have to go through all the same schema evolutions for your star schema in your data warehouse. So think about those things as you're trying to make a comparison of technologies to legacy technologies. Now, in general, I can say that I've seen use cases and I've had people tell me that they've run Drill on Amazon with 1.5, 2.5 terabytes of data in JSON format, and they consistently got answers of that data set between 30 and 45 seconds. That's pretty impressive. Okay? So when you think about that, I'm not trying to tell you Drill kicks everybody's ass. That's not what I'm saying. I'm telling you that it can be really fast. Depending on exactly what you're doing, it's going to be great in most use cases. Now, MapR supports Drill, we support Impala, we support Hive. So effectively, our goal is to make you successful. So what is best for you is best for us. Right? We're not out there stomping and saying you can only use this one technology because that's all we care about. I'm telling you, regardless of which of those technologies you use, you're going to have edge cases you're going to run into. So be thoughtful about it. Apache Drill happens to be my favorite because, quite frankly, I can download it right here on this laptop and I can run queries on data here. That's very compelling. Being able to have such a low barrier to entry, to not require Hadoop, to not require Hive for the metastore, That's a big deal. Really, really simple. So the concept, SQL on everything. It has storage plugins. It's configurable. If you have a new storage location and it's not already supported by drill, you can actually extend it pretty easily and plug it in. If you say, hey, community, help me out with this, right? Lots of people in the community. There's a lot of plugins already. There's more coming. Like, I know that there is a plugin for Apache Phoenix. There's a plugin for Elasticsearch. They're being worked on. They're not quite ready for prime time, but they're out there. They're being really kind of built up by the community and supported. Additionally, you've got this concept of a workspace here, and it's really nice because it helps decouple your data location from where you're running. So if you're running drill here, you could create a workspace called your workspace, and you could test with your data. And then you could take your exact same query and run it on a cluster running drill. And if you have a your workspace that exists there with your data, maybe you pulled off a couple gigs on your laptop, maybe you have a few terabytes on your cluster. You don't have to go changing your queries to be able to access it. And then the last part here is, this is effectively a table. And what's really cool about it is, and I might have an example further in, but this table allows you to also have directories of tables. So if you have your data coming in daily, monthly, weekly, whatever it might be, however you break your data up, and you put it all in a directory, you have the ability to query by directory as well. And so directly inside of your where clause, you can say where directory 0 equals or like this or that. And so you can start filtering out based on your directory structure how you partition your data. So fundamentally, reuse the tools you've got. Since the advent of Apache Hadoop, early days, and I'm as guilty of this as anybody, I wanted people to just drop it. Like, this runs so fast for all these use cases. We can scale it so easily. Did it work? No. Why? Because the people that we wanted to use the tools for all the use cases are people that came from the business side. People on the business side, they knew SQL. They didn't know anything else. Initially, I thought that's a problem. That's, oh, come on, people, just change your mindset. At the end of the day, they were right, I was wrong. The things that they know can be re-leveraged. This is why I like drill so much. So drill would be completely useless if it didn't actually give you some security. Now, I say completely useless in very loose terms because there's still a lot of use cases and a lot of people don't care about security. That's okay. If you want to look at it as broad sweeping use though, security is very important. So when we look at this, we see a user come in through their favorite tool, and that tool talks to drill. Drill can talk to these data sources. It plugs right into your authentication mechanisms. So how does this benefit you? Well, you've got the ability to be able to put views on top of your data. Why is this nice? Well, this is really nice because Hadoop, one of the things that people tried to use it for is they wanted to say, I want to give you access to files. And files are tables of data, right? Liken it to a relational database. Well, what's one of the things you get in a relational database? Security. Well, if you put data in files, it's pretty tough to give granular access to files inherently. You can't do it. So drill has the concept of impersonation. What makes this cool is you could say, for example, I own the data. No one else has read access to the raw data. Now, I can create a view on top of that that says select these fields from this file. So select these fields from this file. Maybe I have special where clauses, maybe I don't, whatever. I can restrict based on columns and rows. That's great. Now this view, whoever I give directory access to, and say this file can be read by anyone in this group, I don't have to have a separate security panel. I don't have to have a separate security management solution. I can just do it from the file system because a view is a file and the raw data is a file. So if I own the raw file and then I create a view and I'm the owner of that view, and then whoever has group permissions to read the view, drill says, oh hey, you know what? I can impersonate this user because that's how I'm set up. And because you have read permission on the view, you can execute the query. So then you can put a view on top of the view and let other people give access in more fine-grained ways. So when you think about this from a personal information perspective, where you might have credit card numbers, you might have social security numbers, right? This gives you fine-grained access to that data. You might want to mask it. Who knows? Whatever you want to do, you can go ahead and start doing with drill. And it has the ability to go through multiple chains of ownership. I think by default out of the box, it will do up to 3, but you can change the number. It's a configuration setting because you could technically run into a performance penalty while it is going through the chaining of ownership to see who owns what and if they have permissions for it to impersonate down to that level. But fundamentally, this is pretty powerful. And again, it doesn't require a third-party metastore like Hive. It doesn't require a third-party security store. It's part of the file system. It makes it real easy to implement. Anybody who owns data can secure their data. So I don't know if it gets much more powerful than this with simplicity combined. The other tools, they may have some impersonation. They may have ways to give you granular access controls. But you can't just download those and install them on your laptop to get running with it. They don't all come with the same types of ODBC drivers where you just plug right into any tool you want. You know, like Excel. And I don't advocate that, it's just you can use it, but it's still Excel. So, I want to walk you through an example. Anybody here ever use Yelp? Yes. All right, so. It's not supposed to be funny. All right, so Yelp has a data set for research that you can download. So this is the example that I want to walk through. So they give you data. It's all structured in JSON. Now, again, I come back to, if you write an application and you serialize your data to JSON, it now becomes very easy for you to do anything you want. And when you start looking at the data sets, we have nested data structures. Well, if you couldn't deal with the nested data structures, that would kind of be a problem. But Drill supports all this. So I've got some examples that will show going through and digging down into some of these different features that are here. So the website says 10 minutes. I say 2 minutes because that's really all it takes. I do just because I've had people ask me, I'm never updating this slide. I made the slide a long time ago. That's all it takes, but I wouldn't download 1.0 anymore. DFS is the file system. When you're installing it local, that's just your local file system. When you're on a cluster, DFS is going to be your distributed file system. So you can group by, you can order by, it's dead simple, you get your results, it's fast. Now, just as a point of reference for you, on this laptop right here, I downloaded public data set from the city of Chicago dealing with theft, crimes, all that good stuff. The data set was 1.2 gigs of CSV data over about a 13-year period. I converted with Drill that data from CSV to Parquet. My queries with Drill on this laptop that I was running would take about 18 seconds. When I converted it to Parquet, it took about 9 seconds. It cut it in half. Does anybody want to guess what happened to the data size of my CSVs? It got cut exactly in half. It was like 660 megs from 1.28 or 1.3, like right on that cusp. So Parquet, much more efficient. All the time that the computer is spending processing these queries is getting data off disk. Okay, so keep that in mind. Small data sets are going to work great on laptops. So for people to do general exploratory analysis, figuring out if something's going to work, laptops work really great. So when you get into the concept of partitioning in relational databases, you can effectively still deliver the same type of concept on a distributed file system with Apache Drill because you can partition your data up into directories. The more files, the more directories you have, the better natural distribution you're going to get across your cluster, which means you have more compute power and more disks at your disposal. So you're naturally going to get faster queries when you can distribute your data more naturally. So being able to drill into these nested structures, it's literally doc notation to go into it. So the table referenced as b.hours.friday. Easy. There's this function here called repeated contains. Well, what happens when you have arrays of data? Well, you don't have arrays of data in a relational database. If you do, you probably did something that you built out yourself. So if you have this concept of an array of data, Drill has extended SQL repeated contains. So these functions can make it very easy for you to get at and find the records you're looking for. Again, pretty simple query over a JSON data structure that could be reasonably complex nested, but it's all self-describing. There's really nothing at all complicated in here. So when we get into the reviews, there's a lot of flexibility in these data structures for reviews, because people could use their own terminology to say, you know, this place like was awesome, right? Maybe you want to be able to search for those types of things. And since it's stored in JSON, you've got that flexibility. Votes, funny, useful, cool. Who knows? So when we get into it, you can do all your general standard ANSI SQL stuff with it, right? You want to say which of these were cool with a count greater than 2,000. That's nice. Simplicity. When we get into the concept of views, right? I want to hide some of the complexities of my queries from users. So again, it's about simplicity here. So do you have to use views? No, but you can. A view ends up being a file in the file system. So I had a conversation with a pretty big company recently, and they were evaluating drill. And they had no idea you could do views. And the guy, he smacked the dude next to him so hard. I felt bad for the guy next to him, but it was out of jubilance. I mean, he was so happy. He said, "Did you know this? Why didn't you tell me this? Oh my gosh." Well, he's like, this will solve all our problems, because as we're figuring out the optimal storage format for these different data types that we have, he's like, we can start out with CSV just to get rolling. We can convert these to Parquet. We can optimize the Parquet. We can do some of these in JSON. We can join these together behind the scenes and see what happens. And the user will never know because they're in the view. It's part of the reason why you have views in the first place, right? So some people have asked me, okay, but yeah, in my relational database, I can do materialized views. I said, what is a materialized view? A materialized view is a table. Some people say, but I can do updatable materialized views. I'm like, there's no such thing as an updatable materialized view. It's a function that that database vendor gives you, and what they do is they swap the table out on the fly from you. You can do the same thing here. You can do create table from a query, and then you can build a script around it to say, create the new one, swap the old one out. Right? You can script it. It's easy. There's no magic there. So you can do materialized views here with create table as. Some of the nice things about this are that you can tell it to output in Parquet format, you can tell it to output in CSV, and you can tell it to output in JSON. So you can actually use this to start creating some simple structures from your data sources if you want to be able to go into a JSON format. Could be useful, maybe it's stupid. Depends on what you're trying to do. So when we get into these arrays of data, you say, but look, I've got to be a little more complex than just this repeated contains. Well, drill has a function called flatten. And so here we've got this array of different categories for this business. Well, if you need to look at the data and break that out into multiple rows, you just say flatten it. And so the result at the bottom ends up, you show one row per item in that array with all the rest of the data duplicated. Pretty important, depending on how you're trying to aggregate your data. So I'm showing you this now because we've got this check-ins concept in Yelp. You check in, it keeps track of hour of day and day of week in this weird format of hour-day. And then it has a count of how many check-ins for that. Well, when you start looking at this, you say, well, this is great, but I might not understand what the keys mean. So drill says, look, I've got this function called kvgen, key value generation. So you take a data set like that, and you say kvgen that check-in info, and it ends up giving you the key is 3-4 and the value is 1. So it basically creates a map for you. You can now identify the keys with the named key and the value with the named values. It gives you the ability to have some flexibility on how you address your data. So then when you wrap that inside of a flatten, you can actually go back into your original format, but with names that you understand of keys and values. And what I should really remind you of is, and I don't think I mentioned it at all, is drill is ANSI SQL 2003 compliant. So all of those complex SQL capabilities like case statements and stuff that some people know about and some people don't, they're all there. So when you get into having these nice BI tools that can generate these pretty complex SQL statements, you're not plugging it into a SQL-like syntax, right? That's one of the issues that I had early on with Hive and Power, is that they use HQL. It's a subset of SQL. Drill is ANSI SQL. Now I've had people say, yeah, but does it implement the entire specification for all the data types? Not everything is fully implemented yet. Drill doesn't support inserts, okay? But as a query tool, in general, for being able to read your data, it's a different use case. So those data types, not really a big deal. So in general, the syntax of being able to read data is there. So, some resources of potential value. Number one, Drill was ranked as the top SQL on Hadoop technology out there, predominantly for the reasons that I've shared with you. It's got about 2 years under its belt with a solid 1.5 years of people using it in production use cases that I'm aware of. There's a whole bunch of free training that MapR offers. Drill is one of the topics covered. Streaming technology is covered. Spark is covered. Hadoop is covered. Basics of Hadoop, essentials, administration, all of those things are all covered. They're all free. They're all on demand. If you want to get into checking out these technologies, and this slide deck will be emailed out to the distribution list. These are some great resources to be able to check out the APIs and implementations that have been built on it. There's Python bindings and JavaScript Node.js bindings for the Ohio API. You can download the sandbox and just get started with it. These are a couple blogs that I wrote that take the National Nutrient Database provided by Food and Drug Administration and walk you through how to query it with Drill. There's a lot of really great queries, so if you just want to dip your toes in the water and mess around with a public data set, you can go through these 2 blogs in order, and it'll show you how to do these different things. And then I walk through an example, including converting some of the data out of that. Here's 12 or 15 tables of data that they give you, and I pulled a few records out and put them in JSON format to show what the queries look like in JSON as opposed to the relational format. So help kind of move you in that direction. It's not meant to say, you should be able to do this with any data set, because it's kind of a pain working out of a relational model back into a JSON format, but you can do it. So if that's for you, awesome. If not, at a minimum, this will help you understand some of these concepts within Drill. And so we've got a lot of available resources out there to be able to work with Drill. I would strongly encourage you to join the mailing list. It's very active. I think that of the times I've asked questions, it's never taken more than a couple hours to get a response. Typically, most are answered very quickly. Every once in a while, there's some obscure question that takes a while for someone to get to. It happens. That's everything I have. Our QA moderator is coming.
Hi. Wow, hands are already up. All right, let's go.
What would be a use case to work with Spark, with Drill and with Spark?
So one of the questions, I get asked the question a lot of, well, do I use Drill or do I use Spark SQL? Okay. Now, it's a great question, really super simple answer. Spark SQL is not ANSI SQL. Okay. That's number one. Number two, Spark SQL is meant to be used when you're programming. If you are working with a general computation engine, you should use Spark SQL. You, technically speaking, can use Drill with Spark because Drill has an ODBC and a JDBC driver. So if you want to run actual full-on ANSI SQL queries, that's what Drill's for. If you're doing basic rudimentary Spark code and you're saying, I've got data in this file and data in this file, I'm trying to join it, Spark's going to hit most of your use cases perfectly fine. If you're trying to compare the two as an engine for executing SQL, don't go down the Spark SQL route. That book that we handed out at the beginning, I wrote that book. That's my book. So I've got plenty of experience working on both of these. We have a partner company over in Japan And they went through and they did a Spark SQL versus Drill showdown at a meetup out there. And they did a side-by-side rundown. They said, we're starting from download to running queries. Drill, they had less than 5 minutes and they were running queries against their data. Spark, they were still going at 55 minutes in before they could start running queries, trying to get everything working properly. So if you're trying to run SQL and that's your goal, use Drill. If you're trying to do programmatic computation, that's what Spark's for.
I work for a company that has Oracle as its foundation, and its interfaces they use Java and Scala. And my question is to move into the MapR kind of relationship where you're using Oracle with these tools. Is that really a viable possibility, or is that overkill?
So it depends on the use case, because Oracle in general gets used for transactional and OLAP procedures, right? So on the transactional side, number one, can you use a document database to handle your transactional workloads? Absolutely, perfectly fine. Is it going to be something your company does for your use case? It's going to depend on the actual data you have and whether or not putting your data in a document store is going to meet your needs. Now, let's just assume you're dealing with autonomous records. And you say, I can swap MapRDB out for Oracle for this use case. That's one option. Am I telling you to go do that? No. I'm telling you to evaluate whether your data model can work in a NoSQL type of model like a document store. If you say, well, we've got an actual dependence on relational data. Alternative option is, I want to be able to get this data out, but I want to be able to use it in an efficient, timely manner. So you use something like Golden Gate, and you do change data capture on your database, and then you send it over to something like MapR Streams, and then you can process that data on the other side, and you can pull it through at any rate you want to. And if you want to store that in a document database, if you want to store it in files, it's your choice of where you want the data at, and then you can do all of your analytics on the other side of it. So you've got options for how you marry up these technologies with your use cases with things like Oracle. So depending on your specific database, like with MySQL, if you do plain file output, right, you can actually run that right on top of MapR over NFS, and you can query those files directly. That's not going to be a best case scenario for performance with MySQL, of course, but that's an option. Other relational databases, or the model that works on there, HP Vertica, tested on top of MapR with NFS, but they don't have an adapter yet that I've seen, and I don't know what their plans are to be able to make Drill be able to query. But relational databases can also run in this environment. SAP and Sybase IQ, they've fully validated their platform to be able to run on top of MapR as well. So Oracle, we'll see where they get to and when, but you've got options with how you want to marry the technologies together to have a proper path forward to be able to benefit with some of these technologies.
Yes.
Can you query Oracle with Drill?
You actually can query Oracle with Drill. You can query pretty much any JDBC driver with Drill, which is kind of weird to some people.
Okay, that's the first time I've heard.
So the plugin made it into Drill, I believe, in 1.2. Drill is now at 1.6, I believe, right? 1.6, if anybody has seen the current version. And you can configure JDBC sources. So I know multiple people who have actually configured MySQL and Postgres and Oracle, and to be able to push down the queries into the data sources. And that's one of the things I didn't really talk about, but Drill has this awesome capability called pushdowns, because each data source may have different benefits of how it's used. So it can push down in a customized way based on the storage plugin, whatever that storage facility can handle. So the JDBC plugin for Drill is still in early stages, but it absolutely does work, and you can join across those data sources.
Yes.
How does Drill deal with range queries? So if I want to ask for something between this and this,
So between is not, I don't believe, officially in the SQL spec.
well, I didn't necessarily.
I got it.
Yeah, okay.
So if you say where something greater than this, less than that, same field, fully supports it. Depending on your storage format, it's going to depend on how it's going to perform as a query. It also does have window functions available. So depending on exactly how you're going after your data, those more complex functions are available to you to be able to go after.
So I know that, I know that Postgres, for instance, has range types, and then you can put like a JSON index on those range types. Does it have anything of that nature?
So drill currently does not have indexes.
I see.
It's not to say you couldn't create your own. So one of the examples I gave somebody recently was like, first off, you could use something like Elasticsearch. And since that plugin is coming for drill, probably in the not too distant future, it's just one example. But the other example is, people always talk about secondary indexing, and I say, well, if I looked at something like just age-based, and I want to say, looking at a star schema model of dimensions, I have my data, and then I have my dimension. And I say, for this dimension, this key has this value. So I create an entry in this table. I can create a secondary index with something like age-based where I combine just the key ID together and put the value after it. And so then I can actually do a range scan right inside of age-based. And I could say, select from age-based where the key is like this combined with this star. And I can pick up all of the rows and get just the keys back. And then I can say, I know exactly which dimensions have this ID and which records have this ID, and they have these values in it. So I now have my all possible values here. And you can then go further in and say, I want to go to my actual data row and pull all the data back, or you can just stop at that point, which most queries that go against data warehouse and star schema actually typically are intended to stop at the dimension lookups. So that is a benefit that you can get there. So secondary indexing is possible. Drill, since it can query and join across data sources, you can do those types of things with it. We'll see when the index functionality comes along for drill. I'm sure it'll be there eventually. The keyword is reserved because it's part of the SQL spec, but it's not there right now.
That's good. Time for just one more question? Wow, that's a lot of hands.
What's the estimated data for, do you think, converting a star schema, or something that's relational but that's in SQL but still a star schema? I mean, let's say 50 tables to something that uses NoSQL.
So converting a bunch of tables in star schema over to be able to work on this model. Number one, that falls into the concept of general data warehouse offload. There's a bunch of different approaches that you can take to it. The most rudimentary is saying dump table to table, dump table to table, and then come at it from the other side, and then optimize as you go. If you come at it where you say, I want to come up with these types of indexing schemes to the most popular types of queries I have, that's kind of where people start evolving to. If you can get it back over to that, instead of taking data out of your data warehouse and get actually at your transactional data, right? That's where you really start picking up your big benefits, because you don't go through the transactional, the transformational process, which takes a lot of time to build, manage, right? And then how many hours does it take to run?
Right.
You can sweep all that out.
Yeah. So you would prefer that as stream data changes from a transactional system?
Ideally, I would say if you can make it one and the same,
Yeah.
that's even better. So if you make your transactional database the source for the queries, it's even better. And so with MapRDB as the example, is you can actually snapshot volumes of data in MapR. And when you think about it from a transactional perspective, data is constantly changing. Well, if you try to do data analytics, you can't have data constantly changing on you. So you can snapshot your volume, get a consistent point in time view of all your data. And because the file system is copy on write, if it was a 10 terabyte table, you're paying no penalty on it. So then you run your queries against that formatted data in JSON. Anybody can come in and get it. And then when you're done building up your models, you say, oh, just run against the live data. I don't care if it changes now. Now you didn't have to go through an ETL process. Some of your queries might be slower, but again, the trade-off is you didn't have to go through an ETL process. You didn't have to move your data from A to B. And so now all of that time works back into your value proposition.
Thank you.
You're welcome.
Okay, so Jim Scott will be here for one-on-one questions for anyone who didn't get a chance to ask them. In the meantime, thank you all for coming. Thank you, Jim Scott.